And now on page 42, it is time for math. Yay, math. Make sure you have a calculator. You will need a calculator. And, of course, you know, like whatever you're writing with in your book, page 42. Before we start the actual math, let's make sure we know the difference between variables versus units. A variable is a single letter to represent something we are measuring. You know, like in your math class, you use X or Y. Here, we could talk about length as something we can measure, and instead of writing out the word length, we could use a lowercase l as the variable. A unit is a standard quantity that we use to express the measurement. The units are written after the number. So for example, length can be measured in many different units like feet or meters. So if we put those two ideas together, like saying a student measured a piece of metal and determined the length is 3.47 meters, this means the length equals 3.47 meters. But instead of writing all of that, we can abbreviate it down to L equals 3.47 m, where L is our variable, m is the unit. So we always end up with a variable is equal to some number, which is measured with some unit. So we have 5 variables we have to worry about. We've got wavelength, we've got frequency, we've got the speed of light, we've got energy, and we have Planck's constant. We mentioned all of these on page 39. So now we're really just coming back to them. Our variable letter for wavelength is lambda, and we measure it in usually meters. Frequency, we use a lowercase f, and we measure it in hertz. You may have heard of them before, Hz, hertz. And I guess I should write up here, m is for meters. The speed of light, we use a lowercase c, and it is in meters per second. And the speed of light, remember we mentioned again on page, whatever it was, 39, speed of light is always 3.00 times 10 to the 8th meters per second. Always. Anytime you need to plug in something for C, you're going to plug in this number. It's a constant. That's why we picked C. Energy, we use a capital E. It is measured in a unit you probably have not heard of before. It's called joules. It's named after a guy, so we use a capital J for joules. And then Planck's constant, we also talked about. It's a lowercase h. It has units of joules times seconds. And again, h is a constant as well. Anytime you need to plug in a number for Planck's constant, you're going to plug in 6.63 times 10 to the negative 34. Always. So these two are constants. The relationship between energy, wavelength, and frequency of any electromagnetic radiation wave can be expressed in 3 equations. C equals F lambda, and this is F times lambda. You can put a time sign in there if it helps you. E equals HF, again that's H times F. Or E equals HC over lambda, H times C over lambda. So there are times signs and all of those. And again, remember, anytime you're using C, you're going to use 3.00 times 10 to the 8th, both there and over here. And you could also type it in your calculator, just 3E8. And whenever you're using H, it's going to be 6.63 times 10 to the negative 34, like right there and right there. And again, if you typed it in your calculator, it would just be 6.63e negative 34. Always. Remember that wavelength and frequency have a relationship that when wavelength goes up, frequency goes down. That's called an inverse relationship. If one goes up, the other goes down. Energy and frequency have a direct relationship, meaning if one goes up, the other goes up, or if one goes down, the other goes down. And energy and wavelength have an inverse relationship as well. When one goes up, the other goes down. So wavelength is inverse to both of the other two. And when you're done writing that, turn the page. When we do math for this unit, we're going to use what's called the GUESS method. GUESS stands for GUESS, given, unknown, equation, substitution, and solution, or just solve. So here's how this is going to work. We have on page, if you look at page 44, there's a bunch of guess boxes. And each one of these sets of guess boxes goes with a problem. So we're going to go ahead and label these right now, like number 1, number 2. This is where we're showing our work for number 1, number 2, number 3, and number 4. Just like with our previous unit, anytime you do a math problem, you have to show your work, all your work, or you don't get credit. What's going to be a little different about this unit is instead of doing a bunch of like fractions times fractions, when we show our work for this unit, we're going to show our work in these guess boxes. So the G box is where we write our given, meaning what's given to you in the question or statement. This will always be something in the problem. You read the problem to find this. For instance, if we look at number 1, it says an electromagnetic wave has a frequency of 548 hertz. What is its wavelength? The given is going to be a, it's always going to be a number and unit, and it should always be equal to some variable. I kind of ran out of room while I was writing that, but some variable equal to a number and a unit. So if we look in number 1, I see a number and a unit right here, 548 hertz, and the variable it goes with, they say it is a frequency of. So that means frequency, our variable for frequency is f. Frequency of 548 hertz, f equals 548 hertz. And this is what we're going to put in the G box, the given box, when we're showing our work. So f equals 548 hertz. That is what they have given us right there. The U box is the unknown. It is what variable we are looking for from the problem, and it's always going to be a variable, and we're going to write it as the variable equals some question mark and then whatever unit it is supposed to be. So when we read number 1, we have to find your question word. Think back to what they would tell you in like 1st or 2nd grade. Find your question word. If an EM wave has a frequency of 548 hertz, what is its wavelength? Oh, here's my question word. What are they asking me for? Wavelength. So this is my unknown wavelength. And if I look back at the chart on page 42, wavelength is supposed to be lambda measured in meters. So what I'm going to write in my unknown box, I know I need wavelength, that's this new Greek letter lambda. It equals some number we don't know, and it's measured in meters. So, and I took those again straight out of this chart. I know wavelength should be a variable of lambda and units of meters. Now this E box is where the equation goes. And you look on your equation sheet, what is the equation that has the variables from G and U above? So in my G box and in my U box, I have an F and I have a lambda. I need to look at my three equations and decide which one has both F and lambda. This one on the end has a lambda, but it does not have an F, so I can't use this equation. The one in the middle has an F, but it does not have a lambda. I can't use that one either. But this very first one has both F and lambda. So this is the equation I need to use for this problem. And I am going to copy that equation directly into my E box. C equals F lambda, or F times lambda. Just like that. The big S box is where we substitute, where you plug your numbers into your equation. We always have to plug something in. So for C, they did not give me anything, but if I look back on my equation sheet, we wrote in several places C is always going to be 3 times 10 to the 8th. We wrote it down here too. So you could even say C is something else you know. It's something else that is given to you, because I'm not making you memorize what C is. And that means that number you're going to plug in for C. So when we substitute, instead of writing C equals, I can write 3.00 times 10 to the 8th equals. Because these are the same thing as each other. And for F, I know F is 548. I'm going to plug that in here. Instead of writing the letter F, I'm going to write 548. And it is times lambda. Now lambda I don't know. That is my variable that I'm going to stay with. So I can write lambda, or I could write a question mark, or I could even write an X. If it makes you more comfortable, you can write an X there and solve for X. Speaking of, how do we solve for X? I want to isolate X. That's what they say in your math class. Isolate the variable. I want to isolate X, which means I need to get it by itself. And to get it by itself, you have to do the opposite of whatever is happening to X right now. Right now, X is times 548. I need to do the opposite. The opposite of multiplying by 548 is dividing by 548. So we're going to take 3 times 10 to the 8th divided by 548. Type it in your calculator. Go ahead, right now. Type it in your calculator. Make sure you use the E button for the scientific notation. If you type it correctly, it should look like that. And your answer is kind of a big number here. Which is fine. We always round to the hundredths place in this class. So this 0.25 with a 5 next to it, that's going to round to a 0.26. This is my answer, which remember was a wavelength, so you could even put wavelength equals or lambda equals. And your answer also needs units. Lambda is supposed to be in meters, so let's make sure we label it meters down here. I know there was kind of a lot going on there. I want to do another problem with you. And the problem I want to do with you is we're going to look at number 4 together. Now, I want to look at number 4. So I'm going to move my page to where I'm writing number 4. And let's read it. Let's take a look. First, we need to find our given. So I go look at number 4, I read it. If a wave has a wavelength of 4.0 times 10 to the negative 7th meters, what is the amount of energy of 1 photon of this wave? Find the number they gave you. It should have a unit with it. And they should mention a variable as well, and they did. It says wavelength of. So that means wavelength, remember our variable for wavelength is this Greek letter lambda. Wavelength equals 4.0 times 10 to the negative 7 meters. And that is going to go in my given box. Wavelength equals 4.0 times 10 to the negative 7 meters. Next, I need my unknown. So I have to go back to the problem and look for a question word. If a wave has a wavelength of blah, 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 what is the amount of energy of 1 photon of this wave? What is my question word? And they are asking me about energy. So energy is my unknown. Remember that energy, we use a capital E, and it's measured in joules. So I'm going to write in my unknown box, E equals some number I don't know of joules. Now I need an equation that has both of these letters, lambda and energy, E. If I look at this first equation, it has lambda, but it does not have E. The middle equation has E, but it does not have lambda. I need this last equation. It's the only one that has both E and lambda. So I'm going to take this equation, I'm going to copy it in here. E equals H times C divided by lambda. Now I need to substitute, plug stuff in. E, I don't know, so I'm just going to keep that variable. Again, if it bothers you to write an E, you could just use an X there. That's fine. Solve for X, solve for E. It's really the same thing. Now, H and C are a little tricky. You have to remember that those are constants. We have the same number for them all the time. So when we use this equation for H, we're going to use 6.63 times 10 to the negative 34. So instead of H, I'm going to write 6.63 times 10 to the negative 34. And that's going to, I'm just putting it in parentheses to make it easier to read. That's going to be times C. And when I use C, I'm going to use 3.00 times 10 to the 8th. Again, I'm just putting it in parentheses to make it easier to read. And both of those could go up in your given box as well, because again, I will give those to you, or Miss Woodlock will give them to you. You don't have to have them memorized. They'll be on the board or on a formula chart or whatever when you take your quiz and your test over this unit. So we have an H, we have a C. They are divided by lambda, and I have a number for lambda. It's this 4 times 10 to the negative 7th, so that's what's going to go on bottom. And from there, I just have to stick this in my calculator. Top times top, divided by the bottom. So go ahead, type this in your calculator. And I'll point out when you get to the end that energy equals some number of joules. Go ahead and type it in your calculator if you haven't already. And when you type it in your calculator, if you type it correctly, it should look something like this. Although if you're using my class calculators, it doesn't go to the next line for you. It like comes out to the side, but it's fine. You get this number if you typed it correctly, and again we round to the hundredths place, so 4.972 just stays as 4.97. But don't forget the scientific notation. E negative 19 means you have to write times 10 to the negative 19th in your answer. when you're done writing that, go to your stamp page. When you're done writing that, go to your stamp page. At this point, it might still be the 16th and 17th, or it might by now be the 18th and 19th, just depending on how far your class got. So whatever it is, I don't know, pick the actual day today. But these guess boxes are going to be worth a stamp. So the problems are on page 43, and the boxes go through page 45. So that's going to be a stamp. And when you're finished with that, Miss Woodlock will give you more instructions.